All right, so now we have Newton's laws of motion, and Newton, again, was given credit for discovering the gravitational force. His three main laws of motion deal with forces in general, not just gravity. His first law, Newton's first law, and we're going to abbreviate it like this, N1L, that just means Newton's first law, is what we call the law of inertia. In fact, write this right here, inertia. In this force, or in this stated force of Newton's, we can say that an object at rest remains at rest. This probably sounds familiar to you. Or an object in motion or moving with a constant velocity continues to move with that constant velocity as long as, in both of these cases, as long as there's no net external force. No net external force acting on it. So an object that's in motion, we'll say this moving box right here across the table, is going to keep moving in that direction. Actually, I shouldn't say table right there because that'll get us a little bit messed up. Tables actually create forces of friction, which will slow it down. But if that box was moving through space and there was no air, there was no anything to slow it down or to create an external force on it, then it would just keep moving forever. Likewise, any box just sitting here with no velocity, sitting there stationary, is not going to spontaneously start moving unless an external force is acting on it. So that's Newton's first law. Objects at rest stay at rest, objects in motion stay at motion unless acted upon by external net forces. This is our way of stating it right here. If the net external force is 0, then we'll say the velocity is constant. Where in this case, we'll say the velocity is greater than 0, or if the velocity is 0 meters per second. Both of those are constant velocities, and they are achieved by having there be no external force acting on an object. Okay, Newton's second law. Newton's second law right here. And this can be summed up like this. In fact, we have it written here over on the right anyway. Force is equal to mass times acceleration. Or you might say the net force, or the sum of the forces all together. When you cancel out all the ones that don't, or that cancel out. The net force, or sum of the forces, is going to be equal to a mass undergoing some sort of acceleration, or the mass of an object times the acceleration of that object. That's Newton's second law. And this is going to be one of the most important equations that we're going to use in all of physics. Finally, our third law, or Newton's third law of motion, N3L, you might call the action-reaction law. In fact, I'll erase that. Action, too many I's there, right? Yeah, I-O-N, action-reaction. And this is oftentimes stated as saying for every action, there's an equal and opposite reaction. And that's true. Any force acting between object A to B, right here, also creates a force, you might say a negative force, or a force in the opposite direction, from B to A as well. This is the kind of force that you kind of talk about when you talk about rockets. You know, a rocket blasts off. It creates a jet force in one direction, and it propels the rocket in the other direction. That's Newton's third law right there, and we'll talk about that later on in the chapter. All right, so those are Newton's three laws of motion. The law of inertia, Newton's first law, again, is based on there being no net force. Objects at rest stay at rest, objects in motion stay at motion unless acted upon by outside forces. So, if the sum of all the forces acting on an object is 0, then we're going to say that it will have a constant velocity. Whether that velocity is 0 or the velocity is some positive velocity, that's going to be Newton's first law. Put a star by this. Memorize this because you're going to need to know what Newton's first law is, the law of inertia.